එකම විදිහේ මගේ experiments එක. Right, write down practical 5. Practical 5. Determination of velocity of sound. Determination of velocity of sound using a closed resonance tube. Using a closed resonance tube. Using a closed resonance tube. And a tuning fork. And a tuning fork. And determination of n correction of tube. 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 Okay, write down materials and apparatus. Materials and apparatus. Materials and apparatus. List down. First one, a tall jar. A tall jar. A tall jar. A tall jar. Right. Second one, glass tube. Right. මේක glass වෙන්න ඕනේ නැහැ. metal කියලා කියන්නේ copper tube සේන සමහරලාට labs වල. That is also fine. Right. Glass tube or metal tube. Glass or metal. As metals, mostly copper tubes are there in labs. Right. Anti-corrosive no copper එක තියෙනවා. මේ නැත්නම් මේවත් තියෙනවා. මොනවාද? brass කියලා කියන්නේ. පිත්තල ඒවත් තියෙනවා. Right. Next one. A meter scale. A meter scale. Or you can say meter ruler. A meter scale or a meter ruler. Tuning fork of non-frequency. Tuning fork of non-frequency. Tuning fork of non-frequency. Of non-frequency. And some water. Set square. A thermometer. Rubber pad. Supporters. And some cotton or sand. Some cotton or sand. Some cotton or sand. Some cotton or sand, right. Look at here. Listen. Listen. So first, look at the board. First, we have to fix this tube. Fix this tube like this on a stand, on a supporter, on the stand, right? And this is a tall jar, which is filled with water, like this. The jar is filled with water. Make it lazy, burn. The jar is filled with water, right? And now we have tuning fork, no? Tuning fork of known frequency with a rubber pad, which means we are going to vibrate the tuning fork and keep this here at the top of the tube, close to, near to the main axis or the center axis on the tube, right? To give a better transfer of energy, right? To give a better transfer of energy, right? And we are starting from the shortest possible length, to make sure first we are going to catch up the fundamental frequency, right? And tell me, this is a tall jar. This is a tall jar, and this is the tube. Both ends open, tube. Supporter. Then meter scale should be fixed here, right? Usually अभी मैं tube वगैरह fix करना, right? मैं ले रही tube वगैरह. So likewise, this meter scale can be fixed. Like this. Then very easily readings can be taken. This is a meter scale, right? Tuning fork that you know already. And water is added here. Set square and thermometer is used to check temperature. Atmosphere to check temperature and rubber pad on supporters and cotton or sand is used to put here, right? Right, first take this down apparatus. Shall we use resonance tube rather than a glass tube? Same. Resonance tube is metal usually, right? Glass tube or metal tube. This supporter is an adjustable one, right? This supporter is an adjustable one. This is adjustable. Apparatus is this. Okay, finished? Write down. And now we are starting with the shorter length. No? We are starting from the shorter length. Tube is immersed. And we are going to slightly increase this height of the tube until the first resonance is heard. Because this is adjustable. This is adjustable starting from a shorter length, which means we are going to ensure that the fundamental frequency is heard at one point, right? So until then, this tube can be adjusted. Adjusting means this can be moved on the supporter like this, up and down, right? Down move karanna because we are starting from the shortest length and increasing the length now. Maybe increase karna. Once this tube is moved upwards, what is happening with the height here, which is open to the gas medium? By the way, now if one side of this tube is dipped in water, immersed in water, tell me how this tube is going to work from the tubes you know. What are the tube types we know? Both end open, both end closed, one end open. Right? Then, कौन में tube में बैठा करने? Tube is both end open, but now one side is blocked by water. Then it acts as one end open, right? It acts as one end open. That's the purpose of using water here, right? The purpose is blocking one side of the glass tube, right? Closing one side. When one side is closed, this is going to act as a one end closed tube. This is going to act as a one end closed tube, right? Then you have to adjust this length until the first resonance is heard. Then at one point, we are going to hear the first resonance. And at the first resonance, we know that is a fundamental frequency. At fundamental frequency, this is what you are going to obtain. This is what you are going to obtain as a pattern, right? And let's consider incorrection of this as E and length from here to here as L1 for the first scenario. And then, now the first resonance is heard, no? We know definitely the second resonance is going to hear if, now this is only lambda over 4. If another loop is added, one loop is lambda over 2, one loop is lambda over 2. Then you have to take this upwards until more space is created here to add the next loop, right? By adjusting the supporter from the supporter, this can be moved. Right? You can release the nut and you can move this upwards. When it is moved upwards, what happens is the height of the tube, which is above the water level, increases like this. The height of the tube, which is above the water level, increases like this, right? And at some point down the line, we are going to hear the next resonance, and that is a consecutive resonance after the fundamental. Then it must be the first overtone, right? Second harmonic, first overtone. It must be the first overtone. First overtone of a one and closed tube is a known one, right? Then that is going to be like this. That is going to be like this, right? For the same tube, there is same V under same conditions. These are different length, let's say L2, right? So likewise, these two are the occasions we are going to find now by adjusting the length, by increasing the length, right? Clear? Take this down too. And it's better if you can have some space here to write lambda and apply the equation, Adisha. Thank you. Write down as theory and take it down. That is better. Write down as theory and take it down below. Apparatus name, right? Write down as theory and take it down. And now we know that this is the first resonance. Make it clear now? First resonance. And this is the second resonance. First resonance and second resonance. First resonance and second resonance. First resonance and second resonance. So if anyone confused, this is also called the resonance tube generally, right? This is also called the resonance tube generally, but resonance tube is either glass tube or a metal tube. That is what it should come in the material list, right? One end open, yes. Finished. These two occasions are two known occasions, right? First resonance and second resonance. See? Considering the first and considering the second, considering the first and considering the second, වැදි චරවුලන්න නේ දැන් ඇස් දෙක ඇරිලා කලින් ෆ්ලැට් නේ දැන් ගොඩක් රවුම් වෙලා හය වෙනකන් අවුලන්නේ පහ වෙනකන් ඉඳියා පහට නේ ගියා හරි finish හරි okay first resonance see for the first resonance wait this is half of a loop. One loop is lambda over 2. Half of a loop is lambda over 4. Right? First again, for the first resonance, then lambda over 4 equals L1 plus E. Right? Lambda over 4 equals L1 plus E. Right? Which means lambda equals 4 times L1 plus E. Right? Okay, I'll consider this as equation 1. For the second resonance, right? Here we have 3 half loops. 1, 2, 3. 3 half loops. One half loop is lambda over 4. Such 3 total length is L2 plus E. Right? Then here lambda equals 4 times L2 plus E over 3. We'll label this as equation 2. Right? Okay, now hereafter we can do the calculation at once. See, and one thing, this is not a graphical method. From the experiments we have, I mean, out of all 38 we have now, right? There are only very few number of experiments without graphs, right? This is also one graph vector, no graph. Usually an experiment is followed by a graph, no? But here there's no graph. Him experiments, you know, around 7, 8, right? Very few number. In all 38, make up. Not a graphical method. We have two equations. We know V equals. What about this? Gas mediums. V equals What is the equation? Speed of wave through a gas medium, longitudinal wave through a gas medium, stationary. Root gamma RT over M, or else you can say gamma P over O, right? Now, gamma is a constant. What is gamma? Ratio between specific heat capacities. R, universal gas constant. T, temperature, absolute temperature. Now, until the experiment is carried out, temperature is constant. It should be constant. We have to keep it constant. To check whether temperature is constant, we have a thermometer here. Thermometer gatte ekai. To make sure that temperature is constant during the period that you are conducting the experiment. So we have to keep it constant. And M, molar mass, right? So same air medium is used in both cases. Molar mass is also same, which means ultimately V is same. V is same in both, right? Velocity of sound through air is same. Gamma is a constant, R is a constant. We have to keep this a constant, and this is also constant because same gas medium is used. Same gas. දැන් මේ room එකේ කියලා වෙන room එකක ගිහිල්ලා ඔක් කරොත් වැරදි. right? එහෙම බෑ. It can change. එකම තැනනේ කරන්නේ. All the setup is here at a single place, single space. Same. So V is same. V is constant. But we know V is F lambda. No? V equals F lambda. Now V is a constant. V is being constant. Look at the board. V is being constant. What about F? Are we changing the tuning fork or same tuning fork is used? How many tuning forks we have now? How many tuning forks? Then kiyat denawa? How many tuning forks we have now? Huh? How many tuning forks? Tuning fork of known frequency. Right? Only one. Only one. Only one. Then tuning fork is also same in both scenarios, which means frequencies, it's resonance no. At resonance, frequency is equal. Frequency is also same. If frequency is same, lambda is also same, which means these two lambdas are same. That's why I didn't use lambda 1, lambda 2. Lambda is same. Lambda is same. Right? Everyone? Okay. මම මේකේ logic එක මොකක්ද කියලා වෙනම දෙන්නම්. This is what I used. නෑ මෙතනම දෙන්නම්. Take it down. මේ දෙක ලියාගෙන. නැත්තම් මෙහෙම ලියාගෙන. මේ line එකේ ලියන්න. V is F lambda. F lambda is root gamma R T over M. Right? Write down. T is constant, M is constant, F is constant. Then lambda should be constant. Take it down from here to here. This is the logic behind. Right? නෑ මේක common. This is not on the first one. This common no. මේක මෙතනින් පස්සේ මේක ඉවරයි. This common. This is not under the first one. This is a common part again. A common part. First and second එක මෙතනින් ඉවරයි. ඔයගොල්ලෝ කවුරු හරි දැවිලාද? ඔයගොල්ලෝ කවුරු? right? මම මේකේ points එක දෙන්නම්. මේ square brackets දාලා තියෙන constants වලට. right? Sambil. Okay, write down below. Write down below. Since temperature, since capital T temperature, capital T, since temperature, molar mass and frequency remain same at both instances remain same at both instances. Lambda should be same right? Okay, now if lambda is same, 1 equals to lambda equals lambda. Look at the word. If lambda is same, lambda equals lambda, 1 equals 2. From 1 you can say lambda is 4 times L1 plus E, and this side 4 over 3 times L2 plus E, right? Simplify this and subject E. 4L1 plus 4E equals right, this cancels, no? Then 3L1 plus 3E equals L2 plus E, right? 3E plus 3 minus E is 2E. 2E equals L2 minus 3L1, right? E equals L2 minus 3L1 over 2. So here we have E. Which means n correction is known because L1 and L2 are known values. Since L1 and L2 are known, n correction is known. Just a calculation. Right? We can easily get the reading of L1 and L2 using the scale here, the fixed meter scale here. Since L1 and L2 are known, E is known. Right? Now E is done. Right? Write down. And then the next part is determination of V now. To determine V, I'm going to consider this equation from here itself. Label this equation as equation A and label this equation here as equation B. A and B, right? Because the purpose is this: to find V, if is known, to find V, lambda should be known. To find lambda, E should be removed. Right? But we are going to remove E because the whole purpose is minimizing errors. Then it comes to the calculation. It will be factored in the next calculation. So therefore, always we try to cancel them off. If these two are from B minus A, if these two are subtracted, E cancels. Then lambda comes. Right? Just playing around with the equations. No graphs, play around with the equations. B minus A. 3 lambda over 4 minus lambda over 4 equals L2 plus E minus L1 plus E. Right? 3 lambda minus lambda is 2 lambda. 2 lambda over 4. 2 lambda over 4 equals L2 plus E minus L1 minus E. E to E cancels. Right? 2 lambda over 4 is lambda over 2. So lambda equals 2 times L2 minus L1. Lambda is known. 2 times L2 minus L1, lambda is known. Right? If lambda is known, it's done now. Apply V equals F lambda. Right? We write here. Then apply V equals F lambda. F is a known value, then V can be determined. Shall I erase here? Write down up to that point. Lambda is known now. Lambda is known. Lambda is 2 times L2 minus L1. Lambda done now. If done now, that's a known tuning fork. Right? Where are you right? Using using V equals F lambda, right? V equals F is a known value and lambda is 2 times L2 minus L1. So V equals 2F L2 minus L1. V can be determined, right? Write down below. Since L1 since L1 L2 since L1 L2 and F are known values. Since L1 L2 and F are known values, both E and V both E and V can be determined. Both E and V can be determined. Both E and V can be determined. Right? That's it. Right? මේකේ තියෙනක බලන්න. මේකේ තියෙන V හොයලා. Right? මෙහෙම හදන්නත් පුළුවන්. Now in the guide, what is given is doing the same after finding V. V හොයන්න නැතුවත් කරන්න පුළුවන්. දැන් මම කරේ V හොයන්න නැතුව. Right? If V is determined, V is also same, no? Right? V එක same නම් we can do the same thing by equating V. Right? ඒක මේකේ තියෙනවා. මේකත් බලන්න. Right? Lambda එක හොයාගත්තා. Then apply V equals F lambda. Then you know 2 V's at 2 instances. Same thing, huh? Same thing. But V one node na. No need to find V because we can argue as V is same. So does lambda is same. Right? That was my argument. Both are fine. Make it away step back in the very because V is determined. Both are fine. Right. Answers are same either way. Answer එක වෙනස් වෙන්නේ නැහැ. හොඳ එහෙම වෙනස් වුණොත් එහෙම වැඩේ වැරදි. Answers are same either way. Right. හරිනේ? So let's mention the method. Write down method. මේ theory එක දැන් මෙතනින් ඉවරයි. Theory is finished, then method. First point. Immerse the tube. First point. Immerse the tube in tall jar. Immerse the tube in tall jar filled with water. Immerse the tube in tall jar filled with water. Second point. Vibrate tuning fork. Vibrate tuning fork. Vibrate tuning fork. Keep it above the open side of tube. Keep it above the open side of tube. Keep it above the open side of tube. Close to center. Next point. Gradually raise the tube by adjusting supporter. Gradually raise the tube by adjusting supporter. Gradually raise the tube by adjusting supporter until first intense sound is heard. Until first intense sound is heard. First intense sound is heard. at fundamental resonance. Until first intense sound is heard at fundamental resonance. At fundamental resonance. Next point. Take the respective length of tube. Take the respective length of tube. Take the respective length of tube above water surface. Above water surface. Within brackets L1. Within brackets L1. L1 using L1 using meter scale. Using meter scale. Using meter scale. Right? Next point. Next point. Raise tube further. Raise tube further until. Raise tube further until. Raise tube further until. Raise tube further until the next resonance. Next intense sound के लिए until the next intense sound. Until the next intense sound. Until the next intense sound is heard at next resonance. Until next intense sound is heard at next resonance. Within brackets first overtone. Within brackets first overtone. Next point. Measure the respective length. Measure the respective length within brackets L2. Next point. Conclude the values of length within brackets L2. Right, last point. Conclude the values of E and V. E and correction. E and V. Velocity of sound through air. Right. Conclude the values of E and V as discussed under theory. As discussed under theory. Okay, listen. Now from here, experiment is done. Right? Experiment is done. There are a few more things as remarks to be given. Any questions about the experiment before moving on? Ask something? No? Any questions? Online? Make lazy. Make athram lazy. What do you think? Any questions? Clear? Clear? Right. Then write down as remarks. Remarks. First point, tuning fork should be kept. Tuning fork should be kept. Tuning fork should be kept at the center line. At the center axis के लिए, at the center axis. At the center axis. of tube just above the tube just above the tube just above the tube just above the tube within brackets perpendicular to axis. Perpendicular means perpendicular to axis. I have drawn perpendicular to axis. For better energy transfer. Next point. Before that, take this down. This is exactly how it should be placed. What? How about that? කතා කරන්නෙත් නෑ. ඔය මොනා හරි කාලවිල ඉන්න හොඳේ තව චුට්ටයි. Last ones. මටත් ඉතින් වාඩිලා හිටියොත් නිදිමත එනවා. මම මෙතන කෑග් ගා හැම යන හින්දා නිදිමත නෑ. What about online? You are awake, right? පොඩ්ඩ ආයෙ පොඩි වෙනවානේ. හරි? Right, finish. Second point. Write down. Second point. Three resonance lengths can be obtained. Three resonance lengths can be obtained for a given instance and average value of all three can be considered as L for better accuracy. Right. See, another important thing. Now, when this wave hits with this water surface, right? This is an air medium. This is a water medium, right? Now this wave, the stationary wave here, hits with the surface. The surface hits with the surface, right? In terms of waves, tell me. One wave phenomenon is going to occur. What is it? Refraction is happening because this is hitting with an air medium, with a water medium. Air medium එකේ තියෙන wave එක water medium එකත් එක්ක collide වෙනවා, right? Then some part of the wave, right, is going to refract through the water surface, through the water medium, right? And it is going to go up until the bottom. මම මෙතන අඳින්න. එබා now this is going to refract. Just say මේ wave එක යනවා මෙතෙන්ට යනවා. ආයි නතර වෙන්නේ නැහැ. And it is going to මෙතනත් ආයෙ එකක් වෙනවා. මෙතන මොකද වෙන්නේ? Now from here this is refraction. At this surface refraction. Due to refraction it goes into water medium. and then it travels through water medium and reaching the bottom. At bottom, what happens? Huh? Bottom में होता है. How many media are involved? Only one at the bottom. Only one, no? Then what's happening? Reflection. It reflects, right? To minimize reflection and actually avoid reflection, a small piece of cotton or sand is used, right? එහෙම වෙච්ච ගමන් මේ වේව් එක මෙතනින් වැනිෂ් වෙනවා. නැත්නම් මේක ආයෙ අනිත් පැත්තට එනවා. මේක ඇවිල්ලා මේ පැත්තට රිෆ්‍රැක්ට් වෙනවා. ඊට එන කරදරනේ දිලා මේ වේව් එක ඉම්පැක්ට් එක. මේ පැත්තෙන් ඇවිල්ලා මේ ආයෙ රිෆ්‍රැක්ට් වෙනවා. Right? That's why either cotton or sand is used. Right? Cotton තමයි හොඳම. Cotton තමයි හොඳම. ටක් ගාලා absorb වෙනවා වේව් එක. Absorption එක වැඩි. Right? තේරුණානේ? Next point. Write down. Next point. To avoid the reflection of refracted wave through water medium, to avoid the reflection of refracted wave through water medium at bottom some cotton or sand is added to bottom. 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 Right? Next point. Variation of temperature during the experiment. Variation of temperature during the experiment. Should be checked using thermometer. And there shouldn't be any variation. Okay. See, one more thing. Now, since this is a water medium here, since there's a water medium here, right? Air medium around the tube, I mean inside the tube, and here around here is a little bit saturated from water vapor, that is vaporized from this tube. Right? We can't stop vaporization, no? So therefore, compared to this normal atmosphere, water here, air medium here is a little bit saturated with water vapor because of the water surface here. Right? නිකන් මේ වගේ එකක් උදේට notice කරලා තියෙනවා නම් ඔය fog වෙන, ඒ කියන්නේ mist එක බාන වෙලාවල උදේට තියෙනවනේ in the mornings, right? More close to water reservoirs, paddy fields, right? Streams, there's more mist compared to buildings and other infrastructure. ඒක notice කරලා තියෙනවනේ. ඔය දැන් කිරියල් ඉඳන් හිමෙද්දි හොඳට බලන්න පුළුවන්. වෙලවල් පහුවෙන ටිකේ දිගටම මීදුම තියෙනවා. හැබැයි ටවුන් ටිකේ නෑ. ඇත්තද? බලාගෙන ඉන්න නිදා. නිදාගෙන දෙන්නේ. බැල්ල පිටින් ඉඳන් පුළුවන්. වරනේ. තල්ගහවිල පාරෙත් අර වෙලමැදිරිකේ එද්දි පුළුවන්. Right? Just notice it. Right? So in the mornings usually when dew forms, right? උදේට බලනවානේ. Around like 6 to 7 වගේ හොඳට බලන්න පුළුවන්. around 6 to 7 okay 7:38 වගේ වෙනකන් තියෙනවා around 6 to 7 you can notice it right on top of water reservoirs and paddy fields or water saturation එක වැඩි areas තියෙන paddy fields water reservoirs right lakes වගේ තියෙනවා lakes tanks maybe rivers right mist is more higher right more fog is there more mist is there compared to the road ඔන්න road එකේ බලන්න road එකේ නෑ දෙපැත්තේ හැබැයි වෙලේ තියෙනවා in the paddy field you can see හැබැයි යන පාරේ අඩුයි compared to paddy field reason එක අරගෙන ඒක ඔක town එකට වගේ ආවම හොඳට බලන්න පුළුවන් right buildings වල ඇත්තම නෑ ඒතර water vapor වැඩි නම් vaporization එක වැඩි when vaporization is high forming mist is forming fog is also higher ඒක වෙන හැටි thermal වල තියෙනවා right ඒක ගොඩක් explain ගන්න නෑ හින්දා ඒතර මෙතනත් point එක ඒක compared to the other surroundings this is more dense with water vapor this area is more dense with water vapor right when water vapor is mixed with air what can you say about density of air inside this compared to that of outside මෙන්න මේක density එකට මොකද කියන්න පුළුවන් density of air inside the tube is it greater than atmosphere or less than atmosphere water vapor is mixed with the air now more water vapor is mixed because of this higher right it is higher so with that what happens is we know V is gamma P over rho V is gamma P over rho as gamma RT over M right when density increases when density increases V decreases therefore you are going to get a value little bit less than the actual value of speed through air right you are going to get a value a little bit less compared to the actual value right for that there's a precaution in the sense there's a alternative method not a precaution alternative method right instead of using a tube like this right a piston can be used labs වල ඒක නෑ right but there is an alternative option එතකොට හරිම value එකක් ගන්න පුළුවන් a piston can be used piston කියන එක දන්නවනේ instead of that a piston like this මෙන්න මෙහෙම piston එකක් use කරන්න පුළුවන් with an arm and moving this part this length can be changed right no involvement of water so therefore in here accuracy is high there is another what we call next step of the experiment if you are taking this experiment to the next level right මේක කරන්න පුළුවන් වැඩක් using a piston but usually in schools we don't have right okay next point write down next point since density of air medium inside tube is a little bit higher compared to that of outside a lesser value for V will be obtained a lesser value for V lesser in the sense slightly less around 328 30 32 ඔන්න වගේ a lesser value will be obtained right take this down මේක තමයි මේක logic එක this one this equation take this down right below that write down a piston can be used right after this one after the equation a piston can be used piston දන්න නැත්නම් piston එක අතන ගන්න this is called a piston a piston can be used instead of this setup to eliminate that error, to eliminate that error, to eliminate that error, instead of that setup, this setup, to eliminate this error. Right. And one last thing, the reason not to use a graphical method here, right? Even though graphical methods are more accurate, right? Even though graphical methods are more accurate, right? Errors are distributed. We don't use a graphical method here. Can you think of any possible reason not to use a graphical method? Any idea? Online? Press number. Huh? Any possible reason not to use a graphical method? Any possible reason not to use a graphical method? Huh? Anything? Listen, one thing is now if you are going to a graphical method, we have to have minimum 6 values, no? Right? Then this should be increased up to 5th overtone. 6 values gonna 5th overtone, right? Then a very high length of tube is needed. Right? Then lambda over 2 gane. From each resonance, it should be increased by lambda over 2. Lambda over 2, lambda over 2. Then when you continue it for 5 overtones, 6 instances, right? The required length of the tube is very high, right? And it takes more time, right? And the other main thing is when the wave pattern increases, overtone number increases, intensity of sound decreases, right? Intensity of sound decreases. Therefore, we are not going to hear the resonance clearly as we hear in these two, right? The most intensive sound is the fundamental, and when we move up, intensity decreases. So reasons not to use a graphical method, right? Last point, write down reasons not to use a graphical method. 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 First one. First one. First one. A very high length of tube is required. A very high length of tube is required. A very high length of tube is required when taking minimum 6 readings. When taking minimum 6 readings. Within brackets up to 5th overtone. Within brackets up to 5th overtone. Within brackets up to 5th overtone. Up to 5th overtone. Second one, second reason. Intensity of sound decreases when overtone slash harmonic. When overtone slash harmonic increases. Hence, for the same point, hence, resonance could not be identified properly. Hence, resonance could not be identified properly. Hence, resonance could not be identified properly. Right. Okay, that's it. And we are moving on to the last one. Right? An easy one. Okay. Make a basics. I mean, basics are here. Setup is same. An easy one. Right. So, what about the condition? Right? All good? Right. Online? ඔන්ලයින් සෙට් එක හොඳයි. මං හිතුවේ බ්‍රේක් එකෙන් පස්සේ බඩු වෙනිස් වෙයි කියලා. දාලා නිදිද දන්නේ නෑ. දාලා නිදියන්න ඕනෙත් නෑ. ඉතින් කොහොමද YouTube live එක? වැඩකුත් නෑ. එහෙම නිදාගත්තේ. එහෙනම් ඉතින් ඔෆ් කරලා නිදාගන්න හොඳ ඩේටාත් ඉවරයි. කොහොමත් ඔක තියෙනවා. online. Are you awake? All good මේ ඉන්නවා කට්ටිය. This is greater than plus, yes. Good, good. Right, let's move on. Practical 5, may 6. Last one. Last one for the day. Last one for the day. 6.